Athar, can you see my screen? Okay. Okay, then we'll start. So today we'll discuss about the hardness testing, impact testing, and composites. So first we'll start with hardness. So do you know a little about hardness? What is hardness? Okay, let me explain. So hardness is a material behavior, or we can say a material response or resistance to localized plastic deformation. So, uh, if we impinge any material, so the response of a material on the localized plastic deformation is called as the hardness. So, hardness can be of three types. First is the scratch hardness. Means in scratch hardness, we test a material by scratching it from a harder material. And the next is the rebound hardness. And third is indentation hardness. So the scratch hardness, first we'll start with scratch hardness. So it is the ability of a harder material to scratch a softer material. Yes, sorry, your voice is breaking. If we can go to the next topic. Impact testing. Okay, okay. Then I'll start with impact testing. Means you hardness you read in the lectures, right? Yes. Okay. So impact testing. So impact means a sudden load. So if any material which is subjected to a sudden load, so the behavior of that material will be different during sudden load in comparison to if we apply means a constant load or a slightly increasing load. So sudden load means strain rate is very high. So at high strain rates, the material behavior also changes. Behavior or response to the applied stress is different. So the impact of during impact there are very high strain rates and sometimes temperatures are also different. So temperatures can also vary and so, what is the material behavior that changes during the high strain rate testing? So, one we know that the deformation of the material. So, is it ductile or brittle? Ductile or brittle deformation. So, if a material which is ductile, like aluminum and steel, so at uh, low strain rates and higher temperatures, they generally show ductile behavior. Ductile means they easily deform, and the fracture mode is also shearing of the pla- uh, of the material. Like if we draw a simple rod, so if this is simple rod and if we apply stress, so the ductile uh, fracture and necking of the material happens, and after necking uh, it it either breaks in a 45-degree angle or at a pinpoint to deformation. So this is the ductile failure of a material. But in brittle, the material just uh, break in two parts without any significant plastic deformation or without any necking. So it breaks in two parts like this. So this is the sorry, brittle failure. So at low strain rates and high temperature, ductile behavior is shown. But as we decrease the temperature and increase the strain rates, so the fracture of the material transforms from the ductile to brittle because the because of the microstructural changes and response of the material also changes at low temperature. So this is for aluminium, there is no change, but for steel, we observe change from ductile to brittle. So that is known as the ductile to uh, ductile to brittle transition temperature. And we can say it as DBTT. So there are two types of testing, CHARPY and IZ impact testing. So in CHARPY and IZ, the specimen dimension is uh, the it is like a rod. So the cross section is 10 cross 10 mm, and the length is 55 mm, and there is a slight notch in the center of this rod, like the V notch. So the geometry of the notch can also differ uh, specimen to specimen, and if we want to see any changes with notch geometry, so uh, the general one is the V notch. So V notch is the so height of this is the 2 mm, and the angle is 45 degree. So this is the standard specimen dimensions for the CHARPY impact testing. And in CHARPY, means if this is a hammer, and here we put the sample. So if we put sample vertically and notches is this side, so this is the IZ. And if we put sample horizontally and notch on the other side, and this hammer strikes on the sample here, so this is right. I'll draw it again. So this is in horizontal position. So this horizontal position impact test is called as the CHARPY impact test. So most of the time the CHARPY impact tests are generally preferred. And the if we talk about the ductile to brittle transition temperature, so if we draw, so the normal impact energy means in impact, we strike hammer on the sample. So in deformation of this sample, some energy of hammer loses. So means we generally calculate the height difference after breaking the sample. Means there will be slight there will be decrease in the height of the hammer after hitting the sample. So the impact energy is calculated as height difference h minus h1. So if we plot impact energy versus temperature for steel, so this is the curve means the variation of impact energy versus temperature. So here we can see that impact energy is very high at a high temperature. Means here it is failing in ductile manner. But as the temperature is decreasing, the impact energy is reducing along this curve. So at this midpoint, we can say that it is changed from the ductile to brittle behavior. So this temperature is known as the DBTT. So we do several tests for this for checking the DBTT temperature. So at various temperature we have to do the same test. So this is the DBTT. So it depends on the different materials also, like crystal structure of every metal is different. Like FCC is there, BCC and HCP metals are there. So all metals show different types of behavior of impact energy versus temperature. So if we draw impact energy versus temperature, the first curve is like this, very high impact energy. The second curve is the normal DVTT curve, and third is the low impact energy curve. So the first curve for which have the high impact energy is the low strength FCC and HCP metals. So the low strength FCC and HCP metals show this behavior, means high impact energy. So these metals are very ductile in nature. So the high impact energy is required to reform, and with changing temperature, this impact energy does not vary too much. So these metals don't show DBTT. And the second curve is for low strength steels, or low carbon steel is we can say. So it shows DBTT, ductile to brittle transition temperature. And the last third curve, which have very low impact energy. So this is for high strength metals. Means high strength metals absorb very less energy and fail in a brittle manner at every temperature. So high strength metals show this very low impact energy for all temperature. So in this also there is no transition in impact energy. Just wait. Okay, I will write it here. Okay. Yeah, so the in impact energy versus temperature, there is one more concept, uh, like if we draw impact energy and it means if we want to see the behavior of fracture appearance and the impact energy versus temperature. So if we the diagram between impact energy and the temperature, and here it is fracture appearance. So the impact energy versus temperature is the curve is like this, and for fracture appearance means here it is 50% uh, sorry 100% ductile and 20, so it is 100% ductile, so brittle, and here it is 100% ductile. So at this temperature means at this point where it is intersecting is 50% cleavage. Oh, it's 50% ductile and 50% brittle. So there are if we set a range of temperature, so at this point where it show ductile nature, this is T1, and at this point, let's say it is T2, this point it is T3, at this point it is T4, and here where complete brittle uh, nature it shows, so it is T5. So I think I have written opposite. So it is this at T1 it is ductile and brittle. So at T, so here T1 is defined as fracture transition plastic temperature. Means here is 100% ductile fracture, or 100% the there is no means fracture appearance is rough. Yeah, one more thing I had to tell, like ductile fracture show rough surface, uh, fibrous uh, surface, and the shear character. With dull texture. And at T2, where it is uh, transforming to from ductile to brittle, so T2 is given as 50% cleavage plus 50% shear. So the fracture appearance will be little shiny, and fibrous, means both type of fracture appearance will be observed on at T2 temperature. At T3, where it is intersecting here, so T3 is uh, known as the temperature average of upper and lower half shell. At T4, T4 is here at when it is transitioning to brittle. So it is known as ductile transition temperature. Means T4, at T4 we can confirm that it is transformed from the ductile to brittle nature. So it is most accepted temperature. to check the DVTT. So at this stage, the Charpy impact energy is almost equal to 20 joule. So when the impact energy reaches to 20 joule, we can say that it goes to this material is experienced ductile to brittle transition. At T5, where it is completely brittle, so it is known as nil ductility temperature. So there will be no plastic deformation. At T5. So there will be means complete brittle fracture. So in this at T5, the fracture appearance will be granular. In the ductile, it is fibrous, and for the brittle, it is granular surface. Granular, shiny texture, and cleavage. Cleavage means we can say flat planes appearing on the fractured surface. So means it completely fractured from the grain boundaries. So one more thing we can say, the 100% ductile fracture is transgranular. Transgranular means the crack is propagating through the grains, and in brittle fracture, we can say intergranular. Fracture is along grain boundary. Okay, so this is for impact test. Now we'll discuss some properties of mechanical behavior of composites. So the composites are made of two materials. So the combination of two materials in which one is known as matrix and second is known as the reinforcement. So so reinforcement are generally the fraction of reinforcement is less as compared to the matrix. Means this is the bulk part and this is dispersed in the matrix. So by combination of this matrix and reinforcement, the overall properties of the material is increased. Means if one material is brittle like metal and ceramic and polymer. So these are primary materials, metal, ceramic, and polymer. If we add these any two of these material means either metal ceramic, ceramic polymer, or metal polymer. So that uh, resultant material is known as the composite. So either this can be there, metal or ceramic, or a metal or polymer. So by combination of these three types of primary material, the properties means resultant properties will also be a combination of these two materials. Means ceramic is brittle and metal is ductile. So the if we make composite from metal and ceramics, in metal is matrix and ceramic is reinforcement. So the resultant material will be of uh, high strength and high toughness. Means high strength is coming from ceramic and high toughness is coming from matrix. So the corrosion resistance is also increased with formation of the composite. The strength to weight ratio also increase. The elastic modulus increases. So strength to weight ratio is, we can also say as a specific strength, sigma by rho, and elastic modulus is also written as E by rho. So both specific elastic modulus and specific strength is high for composites as compared to the primary elements, metal and ceramic. So these increased properties depend on the bonding of interface, means metal and ceramic interface. So there should be a good bonding between these metal and ceramic means matrix and reinforcement. Then only these properties with enhancement we will achieve. So the reinforcement can be in three shapes. Or first we there are first is the two types, continuous and discontinuous reinforcement. So in continuous, long fibers of ceramic or polymer comes, and in discontinuous, short fibers and particles are there. So two types of reinforcement presents. So there are various types of combination between metal, ceramic, polymers, and so the metal ceramic is possible. Metal plus polymer is possible, and ceramic polymer is also we can make. But the if we add means there are some other combinations also like metal metal composite, polymer composite. But the ceramic composite is very rare because uh, if we choose matrix and reinforcement, both of ceramic, so it is generally brittle. So the properties when of the ceramic composites are not very good. So only one type of ceramic composite is present, which is used. This is carbon uh, fiber with graphite matrix. So graphite is also ceramic, but it is softer as compared to the carbon fibers. So this the carbon fiber plus graphite matrix is the only ceramic composite which is used. So this is generally used for nose of airplane wings plus and in the brake plates. So this carbon fiber and graphite matrix composite is used in airplane where strength is required. Next is the strength of the means how the elastic modulus is increased. So according to rule of mixture, two types of loading is there. Means this is matrix. So fibers are aligned in these directions. So first condition is where we apply stress in this direction. So in when a stress is applied in this direction, so both fiber and matrix is straining with the same level. So this first condition is known as isostrain, where strain in fiber and matrix is equal. But if we apply stress in this direction, so in this the strain will be different, but the stress subjected on matrix and reinforcement is equal. So this is isostress condition. So in isostress condition, the elastic modulus is given as elastic modulus of composite will be elastic modulus of matrix uh, fraction volume fraction of fiber plus elastic modulus of fiber multiplied by volume fraction of matrix divided addition of both composite both matrix and reinforcement modulus. So this will give lower bound of value modulus. Means the modulus calculated from this isostress condition uh, is of low value, which is both less than the metric matrix and composite. But in isostrain condition, the elastic modulus of composite is given as mo modulus of matrix multiplied by volume fraction of matrix plus elastic modulus of reinforcement and the volume fraction of reinforcement. So in this condition, the elastic modulus achieved will be highest from both matrix and reinforcement. So it is the upper bound of modulus. So by these two conditions, we can achieve the maximum and minimum achieved modulus after the formation of the composite. And the volume fraction, the total volume of composite is given by volume of matrix plus volume of reinforcement or fiber and volume of void. Means if the mixing is not proper between matrix and fiber, so some void also forms. So this is the volume contribution from the void. Yeah, so this is uh, all for, and we'll discuss the questions, assignment questions now. Okay, yes. So first question is on the uh, means we have to find the correct statement. So hardness is a measure of material response to localized plastic deformation, and it is non-destructive test to measure the strength of material. Second question is which of the following statement are true for sharp impact test? Means A and B. Yeah, the specimen is placed horizontally and test measure the energy absorbed before fracture. A, B, and D. And the fourth option is also correct. Means it is commonly used to evaluate the toughness of the metals. So A, B, and D is correct for this. The next question is in this curve given below for impact testing, the correct combination for A and B is R. Means we have to tell the metals which show the behavior. So the B curve behavior is generally shown by the low strength steel. So where it is mild steel, we are not considering. So this option is wrong. And second option is A is nickel and B is low carbon steel. So nickel show the no ductile to brittle transition temperature, and it is also FCC metal. Yes, it is FCC and it is steel. So this option is correct. Next option is chromium does not show the A curve, so it is also wrong. In the fourth is aluminium. Yeah, so aluminium show the uh, behavior as A curve, and B is chromium. So B is BCC. So BCC also, the fourth option is also correct. So second and fourth option is correct for this question. So fourth question is we have to mark the correct statements. So this is on the temperature related to the impact energy versus temperature graph. So NDT is defined as the temperature below which fracture is 100% brittle. Means NDT means no ductile uh, transition. Sorry, no ductility temperature. FATT is fracture. mm, Fracture appearance transition temperature where 50% means this is T2, where 50% of the fracture is ductile and 50% is brittle, means fracture appearance transition temperature. FTP is fracture transition plastic temperatures. So it is the 100% ductile failure observed. And the fourth option say ductile transition temperature is a point where impact energy is 20 joule. Yeah, so all options are correct for this question. Yes. Next question is on the compression test. So it says, apart from impact and hardness tests discussed in the lecture, compression tests are typically carried out to measure the compressive properties of metals and alloys. In compression testing, if a block of initial height h0 is compressed to h1, the actual compressive strain will be, so true strain is the minus of ln h naught by h1, and engineering strain is e h1 minus h naught by h naught. So in both true strain and engineering strain, both strains are negative because h naught is higher and h1 is less. So it is written that the calculated strain is negative for compressive strains. However, the convention is reversed in metalworking problems so that compressive stresses are and strains are defined as positive. So we just change the sequence of the uh, height difference. So first we have taken maximum H naught and H1, means in the tensile we write as ln of ln of h1 by h naught. But when we take use this equation in compressive, it will be negative to to change it in a positive term. We just flip the terms h naught. So it is ln of h naught by h1, and the engine strain will be h naught minus h1 divided h naught. So if during compression test a cylinder is compressed from 30 millimeter to 10 millimeter, the magnitude of true strain is, so we know the equation, just we have to put the value and find. So true strain is ln of h naught by h1. So it is ln 30 by 10. So ln 3 will give this 1.09. So first option is correct for this. Next question is find the Brinell hardness number. If the load is 2000 kgf, the indented diameter is 1 centimeter, and the diameter of the indent impression is 0.2 centimeter. So the Brinell hardness is unit is kgf per millimeter square. So centimeter we have to change it from centimeter to millimeter. So it is 10 and it is 2 mm. Okay, so the Brinell hardness is written as twice of load divided by capital D and then multiplied by capital D minus square root of capital D square minus small d square. So here capital D is the indented diameter 10 mm and the small d is indent impression. So when we solve this equation, the Brenner hardness will be 630 kgf per millimeter square. The fourth question, seventh question says which of the following are advantages of composite material? So it gives high strength to weight ratio, corrosion resistance, the thermal conductivity reduces in composites. So it means if we want to improve the insulating properties, then composite will be the best choice. So thermal conductivity reduces and the design flexibility increases. So in the seventh question, first, second, and fourth is correct. In eighth question, the purpose of metric space in the composite is to. So the matrix helps in the sharing the load of the reinforcement material. It binds the reinforced material first and second, and it also deform partly for effective load transfer. And fourth option it says like improve Young's modulus of the composite. So the reinforcement which have high modulus it contribute in increasing the Young's modulus. And matrix modulus is less than fiber or reinforcement. So the fourth option is wrong. Means with combination of reinforcement and matrix, the final modulus will be high according to the stress means loading condition. So ninth question say in a situation where we want a good insulation on the material and surrounding is chemically active, then which type of composites are most suitable to use? Yeah, so generally, uh, in ceramic and polymer, the ceramic provide the very good insulation as compared to metal and polymer. So ceramic matrix composites are preferred where good insulation and required with chemical active environment. So B option is correct for this. Next question is a composite is made uh, using fiber reinforcement shown in this figure, and load is applied along the axis of the cylinder. It is given that modulus is 100 GPa of matrix and reinforcement modulus 200 GPa, and volume fraction of fiber is 0.25. So the elastic modulus of the composite along the longitudinal direction. So longitudinal direction is this. So this is the isostrain condition. So in this, the elastic modulus of composite is written as EM FM plus EF multiplied by volume fraction of matrix. So here EM is 100 and if volume fraction of matrix is 1 minus 0.25, it is 0.75 plus 200 into 0.25. So this will be equal to 125 GPa. So the final modulus of the composite is greater than matrix but less than the fiber reinforcement. So the overall means the matrix modulus is increased with the addition of the fiber reinforcement. So the fourth option is correct. Next question is which of the following statements are correct? So this is on hardness. A tungsten carbide cone is used as an indenter in Brenner hardness. Though in Brenner hardness we use only ball. So yeah, B and C is correct. Steel sphere is used as an indenter in Brenner hardness and diamond pyramid for weaker hardness testing. This question is on the fracture appearance of material with varying the temperature. So fracture surface of the same alloy shown for the impact test conditions at three different temperatures. Which one of this is true? So from this picture we can see that this fracture is dull in appearance. It is a little gray and it is shiny. So shiny is the representation of brittle fracture. Little gray means 50% ductile and 50% brittle, and dull is the 100% ductile. So at high temperature, we observe the ductile fracture. So T3 is the highest, and T2 will be less, and T1 will be less than T2. So the first option where T1 is less than T2, T2 is less than T3 is correct. Yes. Fourth option is same as some previous question. So here NDT is defined as temperature where fracture is completely brittle. FATT is temperature where 50% ductile and 50% brittle fracture observed. FTP is a temperature above which fracture is completely ductile, means fracture transition plastic temperature. And ductile transition temperature is point where impact energy is 30 joule. So for the ductile transition temperature, the energy is 20 joule only. So the third option is not correct. Means at 30 joules, some very little amount of plastic deformation will be there. Next question. In this, we have to calculate Brinell hardness. So in this, it is question is same, only uh, the number given are different. So load is 500 kgf. Indented diameter is 10 mm and diameter is indentation is 4 mm. So it is capital D. It is small d. So BHN will be twice of B. So yeah. So 2 multiplied by 500 divided by into 10 into 10 minus square root of 10 square minus 4 square. So this will give 38 kg per millimeter square. So second option is correct. Fourth question is which of the following are advantages? So it is same question. The last question is in a composite material, the volume fraction of the matrix Fm is 0.79 and the volume fraction of the reinforcing phase is 0.19. So which of the following statement is true? So first option say that the remaining volume fraction of 0.02 is void, which gets created when matrix and reinforcement are combined to form composite. So first is correct and others are. So the second option, which is showing contradictory, means such a composite is not possible as the sum of two volume fraction must be one. Yeah, so this is correct when complete mixing of matrix and reinforcement is there. So in lecture we saw that the volume of composite is written as volume of matrix plus volume of fiber plus volume of void. So if volume of void is there, then the fraction of will be 0.02 remaining volume fraction. So the first option is correct for this. 10A. Yeah. So yeah, this is all for this course. So this was the last session. So do you have any doubt for today? admit card, I don't know. Maybe you will receive by uh, mail, or you can check on the website also where you registered. No, it is the multiple choice question. Like the question we solve in the class only. It's a numerical and the multiple choice and multiple choice and multiple select questions. Okay, thank you. All the best for the exam. Oh, thank you. Okay, then we can end the session now.